Okay, I want to introduce my project. First, a distance. This is the distance controller. Okay, and I set distance, select the distance controller, and reset. Okay, let me demo it. It crashed again. Okay, let's see the code first. For the distance controller, I set the maximum linear speed and the maximum rotation speed, which I can find on the website. And second, this is the given XY value. You can change the value here, and the speed represent the linear speed. And what else? Oh, I declare 2. And the rotation speed will be the linear speed over 2 pi times 0.05 2.5. This is the radian of each wheel. Okay. So what else? And I set the left wheel rotation speed and the right wheel rotation speed both equal to the rotation speed. Okay, and demo it. Yeah, it goes through the line. It should be 8 seconds, right? 8 seconds. I set y equal to 8. So as it finishes, it will display the plot, and the x-axis is the distance, and this is the y-axis, which represents the time in second. Okay. For the exceed, so I introduced all situation where exceed the maximum speed. I set the rotation speed, left wheel or right wheel rotation speed must less or equal than the maximum rotation speed. Otherwise, it will present the statement exceed a maximum velocity. Let me try. If I want to use maybe 4 seconds, save it. Let's see what happened. Well, it doesn't raining. It doesn't run because it already exceed the maximum speed. So reset as 5 seconds. Okay, let's see what's wrong. Okay, it was still wrong. It will also output the distance and compare to the time. So I make it as 2 less and mapping it 2 less, and I add the number into the less, and I'm mapping it and save it into the distance versus time txt file. And okay, this is the whole thing for the distance control. Okay, I want to continue to introduce the orientation controller. I already select the orientation controller. In this controller, at the previous one, I also declare 2 less, the angle less and the time less. And I set the maximum rotation speed, which is equal to 6.25. And the length is the axial length. This is I set equal to 0.058, which is millimeter, but the unit right now is meter, so I already converted. And wheel radian is equal to 0.02.5. Let's see what else. Okay, 180. This is degree, which you can modify right here. and y is equal to 2 seconds. Okay, and I get the radian number, which is x, the big capital S, capital X divide 57295. Okay, and I get the omega. Omega represent the angular velocity of the big circle, the round circle, and the wheel velocity, a linear velocity, which is equal to omega time the axial length. This is the I think this is the radian of the circle around the circle, and I also convert it into radian per second. Okay, let's see anything else. Oh, one thing is very important thing I have to mention is the left wheel velocity, which is equal to negative right wheel velocity. So this is pretty important. Okay, let's see. Let's demo it. As you can see, it will run the half circle in 2 seconds, and I also plot the graph. Okay, and if your wheel velocity radian greater than the maximum rotation speed, it will pronounce. Let me see. It will print the exceed the maximum rotation speed. Okay, this is for the orientation controller. Okay, I want to continue to introduce the rectangle controller, which I think is pretty complicated, but not hard, just complicated. So first you have to set the axial length, which is equal to 0.06, declare the robot, and set the maximum linear speed, which is convert from maximum rotation speed. And also we have to set when it turns 90 degree, I set the speed, rotation speed will be 0.1 times maximum rotation speed. And radian 90 means it turns 90 degree, and rotation time and length. Oh, I have to mention here the length 90. It represents the how do you say, each wheel each wheel across the line when it turns 90 degree. Okay, let's see what else. And I put the initial x value into the left wheel and right wheel speed. This is also the rotation speed. Okay, let's demo it. No. I'm sorry, this is the orientation. Rectangle. Okay, let's see. What's wrong with that? Rectangle. As you can see, it will go straight and stop and turn a 90 degree and continue to go straight and then to 90 degree again and go straight and turn 90 degree again and go string and stop. Okay, this is the if statement to control it go string line or turn 90 degree or continue to go string. And yeah, once the distance is reached to the whole length of the rectangle, it will stop. Okay. And also if you set the x value, which the rotation speed exceed the maximum rotation speed, it will print exceed the maximum speed. Okay. And okay, I want to continue to introduce the last part, the circle controller. Okay. First, I set the axle length equal to 0.055, and the maximum rotation speed, which is equal to 6.28. And I also ask the user to input the 30, which is the hertz, and R1, which represent the radian of the big circle, which is the motor around. So this is the linear speed, and convert it to the rotation speed and set into these two value, the left wheel or the right wheel. Okay. See what else. Once the left wheel velocity, the rotation speed, less equal than the maximum rotation speed, and the motor will move. Otherwise, it will exceed the maximum rotation speed. Okay, let's see. It will run a big circle, and the radian will be given like 0.5 meter. Turn it around. Okay, let's see what if I wanna move it faster or big circle. Maybe I can put 5 meter. I think it will crash or print the exceed the maximum speed. Let's see. Yeah, you see it doesn't moving because it exceed the maximum rotation speed, right? Okay, I put it back 0.5 and hope it moving. Okay, still moving. All right, this is the whole thing for the Lab1, the controller. Okay, thank you for watching. Goodbye.